Zinc is used in baby powder and sunscreen cream. Zinc is also a trace element essential to our health and important in maintaining our senses of taste and smell. Hot-dip galvanizing with zinc is used in all areas of society and our daily lives. Surrounded by ocean, humidity in Japan makes steel prone to rust and corrosion. But hot-dip galvanizing allows the use of steel to be maximized. Hot-dip galvanized steel is also a new environmentally friendly material, combining the strength and workability of steel with the durability of zinc. In the current shift to close the loop of our consumer-oriented economy, the three most important keywords are the 3 R's: reuse, reduce, and recycle. Hot-dip galvanizing converts steel, forming the basis of social capital, into an environmentally friendly material, allowing us to realize the 3 R's and create an advanced closed-loop economy. Hot-dip galvanizing is a technique in which steel is immersed in molten zinc to create a zinc film on the surface. Looking at the cross-section of the galvanized coating layers under the microscope, an alloy layer can be seen between the zinc and steel. Unlike with other techniques, such as painting and electroplating, this alloy layer strongly bonds the zinc and steel, so the zinc does not peel off even after many years. The galvanized surface is covered with a zinc oxide film. This zinc oxide film is denser than an iron oxide film, which makes for a stable material that is difficult for air or water to pass through. Galvanized coating is tougher and more resistant to scratches than paint. Where the steel substrate becomes exposed due to scratching, the zinc around the scratch dissolves faster than the steel, electrochemically preventing corrosion in the steel through sacrificial protection. As a result, rust and corrosion do not progress in galvanized steel. When steel surfaces are finished with a coating of paint, the paint is often scratched during transport or handling. The steel substrate then reacts with air and water entering from the scratch, causing rust. The paint then peels off as the corrosion expands. Hot-dip galvanizing transforms steel into a new environmentally friendly material that does not rust or corrode. Hot-dip galvanizing offers excellent corrosion resistance and durability. The service life of hot-dip galvanized steel. When used outdoors in open-air settings, the service life can be calculated for each environment from the corrosion rate of zinc and the zinc coating thickness. Here are the data on corrosion rates in open-air environments based on 10-year exposure tests conducted by the Japan Galvanizers Association. With a zinc coating of 550 grams per meter squared, a thickness of approximately 77 microns, galvanized steel has a service life of 112 years in rural areas, 62 years in urban and industrial areas, and 25 years in coastal areas. One feature of hot-dip galvanizing is that the zinc coating thickness can be adjusted to suit the environment, and the service life can be calculated in advance depending on its purpose of use. Galvanized steel is also economical. Compared to the initial cost and maintenance cost of painting, hot-dip galvanizing requires no maintenance and ultimately costs less than painting after 10 years, even for a 15mm layer with relatively high initial costs. And by the 30th year, the total cost is less than 1/3 that of painting. The initial cost of hot-dip galvanizing is said to be high, but it is more economical than painting at thicknesses of about 10mm or less, as in thin steel plates. Hot-dip galvanized steel is typically used as is. However, when used in environments where it is prone to corrosion due to salt from the ocean, or where maintenance is difficult, galvanized surfaces may be painted. While this increases the cost, hot-dip galvanizing with a coat of paint is known to increase surface life by 1.5 to 2 times in all open-air environments. Furthermore, galvanized steel for buildings in urban areas and national parks that need to blend into the surrounding landscape are coated with paint or a chemical for aesthetic reasons, as well as to improve corrosion resistance and durability. Hot-dip galvanized steel is a structural material that meets the needs of the times. It has excellent corrosion resistance and durability, is economical, and visually appealing. Steps in the hot-dip galvanizing process. Degreasing. First, the base steel to be galvanized is immersed in a heated caustic soda solution or other alkaline degreaser to completely remove any oil, paint, or other contaminants on the surface. Cleaning. The steel is thoroughly rinsed with water to remove residual degreaser on the surface. For galvanizing small parts, fine steel shot is blasted onto the material to remove oxides, slabs, paint, and other contaminants to ensure adequate coating thickness and improve adhesion. Pickling. Acid wash, such as hydrochloric or sulfuric acid, is applied to remove surface rust and oxides and expose a clean steel substrate. Fluxing. The steel with the metal surface exposed is fluxed to prevent rust and facilitate the alloy reaction between the iron and zinc. The steel is immersed in a heated solution of zinc ammonium chloride, or flux, to form a coating of flux on the surface. Drying. After fluxing, the steel is dried to suppress the spattering of zinc during galvanizing. Galvanizing. The steel is immersed in a bath of molten zinc to create the zinc coating. The temperature of the molten zinc and immersion time are vital to the galvanizing process. The galvanizing process is optimized to match the shape, size, and quality of the steel being galvanized. Quenching. After galvanizing, the product is quenched in warm water. Quenching stops the alloy reaction between the iron and zinc. Finishing. Excess zinc is removed, and the product undergoes other prescribed finishing processes. When galvanizing small parts, parts are placed in a centrifuge to remove excess zinc. Then their surface is cleaned with ammonium chloride solution before quenching. Inspection. Given that the quality of galvanization affects corrosion resistance and durability, the steel is inspected closely. It is checked both numerically and by rules of thumb for appearance, zinc coating thickness, adhesion, and other features to ensure that the coating meets the requirements of its purpose of use before shipping. Hot-dip galvanizing plants have dust collectors and wastewater treatment facilities in paying close attention to environmental friendliness. Robots are also being deployed in small parts galvanizing processes. The galvanizing plant has systems in place for separating and recovering zinc from galvanizing jigs and poorly galvanized products. Zinc, the coating material, and base steel are also recovered from recycled steel scraps. Hot-dip galvanizing plays an important role in closing the loop in our economy. The galvanizing process is tightly controlled to deliver high-quality galvanized products to the public. Hot-dip galvanized steel is used in various situations in society for its superior properties. In the field of architecture, it is used in exposed steel frames, such as on high-rise buildings, which are difficult to maintain. It is used in structural materials for coastal and riparian buildings. It is also used in greenhouses, which are prone to corrosion due to high humidity. In the civil engineering sector, such as transportation networks, it is used in various long bridges, large box girder bridges, and overpasses. It is also used for sound barrier supports, guardrails, signposts, and lampposts in the expansive road network. Galvanized steel is used effectively in factories, plants, ships, and other environments where steel is prone to corrosion due to salt, especially in coastal industrial zones. Due to the minimal maintenance required, galvanized steel is also used in radio towers, transmission towers, aerial hardware, and station buildings. These products are also seeing expanded use in the fields of agriculture and fisheries, such as in cattle barns, chicken coops, fish pens, and piping for polytunnels. Hot dip galvanizing also helps to keep artistic structures beautiful, both indoors and outdoors. Given the durability, hot dip galvanizing has also proven useful in rebuilding and restoring traditional buildings, such as at Ise-Jingu. A variety of leisure facilities prone to corrosion, including the beams and water slides of indoor pools, ski lifts and jumps, and stadium roofs, also benefit from the corrosion resistance of hot dip galvanizing. The superior durability of hot dip galvanizing in various environments helps to support and enrich society and our daily lives. Hot dip galvanizing offers excellent corrosion resistance, durability, and economy. Steady progress is being made in development in search of ever better corrosion resistance and durability. We have already commercialized hot dip galvanized aluminum alloy coating for better durability and low gloss treatment for blending in with landscapes. Demand for hot dip galvanizing has also continued to increase in new fields, such as in galvanized rebars, which extend the service life of reinforced concrete. Environmentally friendly and cost-effective, the possibilities for hot dip galvanizing will continue to expand in the new energy sector, such as for solar and wind power generation. Hot dip galvanizing makes steel products more durable and cost-effective. Hot dip galvanizing will allow us to close the loop in our economy by reusing, reducing, and recycling.